Okay, so what I want to do right now is I want to hook up some sort of sensor to my robot. Obviously now I can do dead reckoning, I can do dance, I can do anything that runs in a loop, but it doesn't have any way of sensing its environment, making any kind of decision depending on where it is or what it runs into. And these little bump sensors are super easy to use and pretty straightforward. You can see what will happen is we're going to hook up wires here to these rods that stick up. Okay, they're going to work like pins, and we're going to plug it into the motherboard. And to mount this, it's not really difficult at all. You just need a couple of screws and nuts, and they should line up nicely in the front, like so, and put some nuts on below. So what I'm going to do is I'm going to mount it, and I'll be right back. Okay, so you can see I've got it mounted here, and it's nicely attached. There's two nuts on the bottom. So now what you need to do is get 4 of these sort of male-female wires. And what should happen, these might be a little firm. I'm actually going to split these, I think, into groups of 2. We want one of these on each side to be ground, and I think this is a logical pin to hook to ground. And one of these is going to go to signal. And I'm going to choose, in this case, a fairly obvious choice. I'm going to choose the black one for ground, and I'm going to go ahead and put it in here. Some of these are kind of firm. It should slide over there. Maybe a little twist to kind of get it anchored in. And then we're going to do the same thing here with this one. I'll choose gray for ground this time. And I'm going to go ahead and insert this onto the ground pin. And I'm going to insert this onto the signal pin. Like so. Okay. Now what you want to do is you want to plug the ground one into the ground bus someplace. Anywhere along the blue line I think is going to be fine. And I'm going to take this gray one. I'm going to do the same thing here. Now, it really doesn't matter. This is going to be a digital, so you know, you could put them all on the digital side, but ultimately I think we're going to want to keep easy access to the micro USB port on the chip. So I'm actually going to choose, for the one here on the right, I'm going to choose the first available open port, which is going to be this one, which is 13, 14, 15, 16, 17, 18, 19, 20 in my case. And then I'll put this one up here. I haven't used it yet. I'll go ahead and use pin 0. Okay. So let me go ahead and set up a little bit of code and explain it, and we'll get this guy steering around with bump sensors. So I'll be right back. Okay, so let's go over what I've done here. I've already wrote a little piece of code and gave it a quick test. It works perfectly, which is awesome. So the first thing I did is I created 2 new globals up here. I called it R bump and L bump for the right and left bump sensors. And like I said, I have the right one hooked up here to pin 20 on my Teensy, and I have the left one here hooked up to pin 0. And of course both of them have this pin here, the outer one, hooked to ground. So if we scroll down a little bit more, there's a really important piece of code right here. Okay, right here. So what I've done is I set the pin mode not just to input like you might expect, but I've done something called input pull-up. All right, and what that means is it turns on a resistor inside the microprocessor here that's going to provide power to the pin. So what we do is we flip a switch, and then the pin, let's say this is pin 0, becomes charged with a very weak flow of electrons. There's a 30,000 ohm, I think, resistor right here, which is feeding it. So right now, when it's hooked up and this input pull-up resistor is turned on, there's electrons piled up on this pin. And if I ask this pin at any time what its state is, it's going to say that it's high because it's full of electrons. There's a resistor here hooked up to 3.3 volts that's charging the pin. Okay? And so when I ask it if there's no escape for the electrons, it's going to say that it's high. It's going to have a charge on the pin. But when we make a jump to ground, okay, when this contacts this, then what's going to happen is it's going to give it a path for those electrons, which are currently piled up on this pin, to escape to ground. Then when I ask it, well, what state are you in? Are you high or low? It's going to say that it's low, because we've connected it to the ground. So we can simply ask the question, are you high or are you low, once we have established this input pull-up. And you can see I do exactly that. So in the loop, here's the entire loop. Okay, here's the close, here's the open. So I ask a couple of questions. If digital read, the R bump sensor, is equal to, okay, I'm actually equating it. I'm not telling it to be 0. I'm asking if you are 0. So I have two equal signs here. So if it is equal to 0, then let's throw it into reverse for half a second, and let's turn left for half a second. So we'll back up a little bit and we'll veer away. Now I have an else if condition. Okay, so if that one is false, it goes down to the next one. Okay, so if it wasn't bumped or if it wasn't touching, it immediately skips to the next one and asks it whether or not it is high or low. Okay, and if it is equal to low, equal to 0, in other words, this wire is touching, so the electrons are free to escape the pin, then we're going to throw it in reverse for half a second. We're going to turn right for half a second. Now, if neither of these two are true, then it's going to go down here to the else statement, and the else statement says, well, let's just go forward for 10 milliseconds, just a little step, okay? And then we're going to go ahead and get in a loop, and we're constantly going to check the right and then the left, and then we're going to go through. Now you want to have this in an if, else if block, because if you didn't, if you just had if conditions asking it, and then you went to forward, well, what it's going to mean is it's always going to step forward, regardless of whether or not these two conditions are true. So it would throw in reverse and then turned, but then it would immediately have went forward. So it may or may not matter so much, but this is a nice sort of logical pathway. Okay? And so let's go ahead and load it up and see what happens. So you'll notice I can turn it off by uncommenting the stop bot, but I'm going to have it go forward as my default. So we load it up. And what did I do? I think I spelled it wrong. Oh, I did. I used lowercase. So sorry. Give me 1 second. All right. Alright, so you can see it's moving generally forward, and if this bumper sensor gets hit and goes to ground, the electrons escape, and it immediately goes reverse and then turns. And if I hold it, it continues to go reverse and turn. And although the lighting's a little bit odd, let's see if I can make that, you can also see I haven't changed that LED, so it's still indicating what's happening by changing the colors. And then if I go over here and hit this bump sensor, I have the same effect, except I turn in a different direction. Okay? So I think the next thing I'm going to do, I might do a little video of this in the next video on the floor so you can see it, and then I think we're going to hook up the grayscale detectors down here so we can keep it inside of an arena with a black border. So I will see you again soon.